These are the NEET 2016 questions on the de Broglie concept. The question says, an electron of mass m and photon have the same energy E. The ratio of de Broglie wavelengths associated with them is how much, right? So when you talk about an electron, for electron, de Broglie wavelength is h by p, that is mv. P can be written like root of 2m into kinetic energy, as kinetic energy equal to p square by 2m. That's the lambda of the electron. Then I need the lambda of the photon, right? You know, for a photon, E equal to h nu, that is hc by lambda, that is lambda of photon. That implies lambda of the photon is hc by E. Here I called energy as k, so here also I will call it as E. So hc by E. Now he is saying these two energies are equal, having the same energy. Therefore, I can equate the energies and I can find the ratios of the wavelengths. So what we can write is ratio of lambda length of electron by wavelength of the photon is, wavelength of the electron means h by square root of 2m of E by hc by E. So this is h by root 2 me and E by hc. H and h can be cancelled, and these energies are same, therefore these energies can be cancelled further. So what is remaining? So if you simplify this, out of this one root of square root of energy, one energy can be cancelled, that is root E by root 2m and c. So the answer is 1 by c of E by 2m under square root, that is whole power of half. That is this answer. Option 4 is the answer for that problem. Let's have a look at the other problem. It says electron of mass m, de Broglie wavelength lambda, falls on a target of an X-ray tube. The cutoff wavelength of the emitted X-ray is. So for an X-ray of cutoff wavelength lambda, energy equal to h nu, that is hc by lambda naught. That is the energy of the X-ray. Now he is saying what is the wavelength of that electron. So for this, wavelength of electron is, what we can write a formula is lambda equal to h by root of 2m into kinetic energy in the place of p. Here also I have used this, right? From where you are getting that kinetic, actually wavelength lambda equal to h by p, but as I have written, kinetic energy is p square by 2m. It implies p equal to root 2m times of kinetic energy, that is h by root of 2m times of kinetic energy. That's what I have written here. Lambda equal to h by root 2 me, where E is the energy of the X-ray for a cutoff wavelength. For that I can write a value hc by lambda naught. So what happens to that value? It implies lambda equal to h by root 2m, the place of energy hc by lambda naught. So let us square this equation. Lambda square equal to h square by 2m hc by lambda naught. That lambda naught will come to the numerator automatically. That implies lambda naught equal to 2m hc by h square of lambda square. One h can be cancelled, that is 2mc by h of lambda square. Lambda naught equal to 2mc by h of lambda square. Option number 1 itself is the answer for that problem. That's how we solve these problems. All these are very simple and basic concepts. You only need to know the basic formulas like de Broglie concept and de Broglie wavelength. Once if you know that, we can simply solve these problems. Thank you for watching.